Bonjour and welcome to WASA Distance Education Center and PLAR Science. It's a little bit of a techno techno glitch there. Okay, I'm on. Okay, so welcome to the first week of Term 1B, and Term 1B begins today, November 10th, and it will end on January 23rd, 2026.
Recording in progress.
So all students are welcome to join the radio Zoom classes. So that's my first announcement there. And for tomorrow, just a reminder to everyone that the WASA office will be closed on Tuesday, and that's in observance of Remembrance Day. So classes for Tuesday, tomorrow, will be canceled because we will be closed for tomorrow. So the lineup that we have for Term 1B Radio Zoom timetable, beginning with Kobe, we have the DC030, that's the co-op. We have the PLAR Science on Mondays and Wednesdays for this term, and then Bonnie will be teaching PLAR Math on Tuesdays and Thursdays. There's a break from noon till 1, and then we have NBV with Elliot, Monday to Thursday, then Doug's class for ENG 3E, so students taking the grade 11 English course. That's the class time, 2 to 3. We have LNCAO, this native language with Margaret. Then we have the grade 12 English with Jillian from 4 to 5. And then we have the MHF 4U, that's the university course, math course with Andrew from 5 to 6. So again, students, you can register for IL courses at any time, but you must complete the course on or before June 12, 2026. So if you're registering for IL, the Radio Zoom classes, this is for 9 weeks. As I mentioned, starts today, November 10th, and then the 9th week would be between January, it ends January 23rd, 2026. So students are encouraged to call their teacher, and if you're doing IL, contact your teacher marker for help at 807-667-3703. You also will have their email if you want to contact them that way. We have 2 education counselors. We have Mary, she looks after the PLAR students, and we also have Michelle, who looks after the other courses. If you're a potential graduate, make sure that you check in with your teacher or grad coach. Our grad coach is Ronalda, to make sure that you're on track to finish all your courses by the June deadline. So remember, potential graduates, make sure that you're keeping in touch, especially if you have 1 or 2 courses left to do. Make sure that you're on track to finish these courses before the deadline. A big congratulations to our Term 1A winners. So these are the students who submitted work and earned a credit. We'll be reaching out soon to let you know about your prize. We will continue to do this end of term draws. So if you submit work during each term, your name will go in for the draw. If you earn a credit, that will go into the draw as well. These are 2 ways to win. Junior PLAR students, if you were previously registered and would like to finish your required PLAR subjects, make sure that you contact us. We'd be happy to sign you up for the 25-26 school year, so it's not too late. PLAR students are students that are missing their credits for grades 9-10. So when you do the junior PLAR, you will be given the PLAR subjects that you need to complete so that we can give you the equivalent missing credits that you need for grades 9-10. Couple of things for eligibility. So you have to turn 18 on or before August 31st. So if you're already 18 and up, then that shouldn't be a problem. And you have to have fewer than 26 credits. So those are a couple of things to keep in mind. And since some of you were with us last time with WASA, we have made some changes to PLAR. So if you haven't been back with us for a couple of years, by signing up in PLAR, you now have the option to skip the lessons and take the open book tests instead. So if you're interested in doing that, let us know. So remember, different culminating activities, and again, it depends which PLAR subjects you need. There's English, math, history, geography, and science. Some students will need to do them all if they do not have if they're missing all 16 grade 9, 10 credits. If you're only missing a few, you might only have to do 1 or 2 of the PLAR subjects. Now, those of you who are choosing to complete the lessons, make sure you have lessons 1 to 5. Lesson 1 is astronomy, lesson 2 is biology, 3 is chemistry, lesson 4 is physics, and lesson 5 is environmental science. Now, if you have previous versions of these lessons and you have completed key questions on them, I will accept the submitted work. And then moving forward, I will give you the most current lessons. Okay, so don't throw out the previous versions of these lessons, especially if you have completed key questions on them. Our YouTube channel, so this is the Wassa Distance Education Center YouTube. This will feature both this term, so this term 1B classes, and we'll also have last year's. And each course is organized into its own playlist so that you have easy access to the lessons. So make sure that you check this out and hit the subscribe button. Now you can use this as support while you're working through your key questions or culminating activity. So if you go to the link that I have here, this is what it looks like. There's the Wassa Distance Education Center YouTube channel. You have a few choices here: home, videos, podcast, playlist. Go to the playlist. So you can see there, it says PLAR Geography 2025-26. So it's been updated 4 days ago. There's ENG 4C, so students, especially potential grads that are working on their ENG 4C, you can check out the classes there. Especially if you're working and you don't have time to go to class, you can use the YouTube video to view your classes. If you're working on your NBE 3C, okay, the full class is there. There's 30 videos. Those of you doing the OLC 4.0, for example, your literacy course, it's right there, and there's 34 videos on that. So make sure you check that out if you're needing some help with your key questions. Now, for those of you, if you don't have Wi-Fi or internet, you can still get a USB with all the classes. Just make sure your device has a USB port. So most of the televisions, they have that now. Everything's organized by subject, then lessons with key questions included. So here's an example of the PLAR Science. So if you get a USB with PLAR Science, there's the subject, there's the lesson number, and it tells you the key questions that's included within that video, just to make it easier. Okay, once you are ready to submit your work for marking, whether it's your culminating or key questions, you can use your iPhone Notes app to do that. You can open the Notes app on your iPhone. You can tap the camera icon and choose Scan Documents, and then you can scan each page of your work. Hit Save at the very last page that you want to send in, so that it's all included in one document. If you choose to take a photo, use your phone's camera to take a clear picture of your work. So make sure you double check. If you can't read it, that means, or more likely, we can't either. So just double check to make sure that the picture that you're sending is not blurry. Emailing your work, you can email us directly. You attach your scanned document or photo to an email, send it to studentwork@nnec.on.ca, and then CC to the teacher that's marking your work. So if it's history, science, or geography, make sure you CC to me. If it's English or math, make sure you CC to Bonnie. So here's an example. You can put on the subject PLAR history key questions 1 to 12, or if it's PLAR science key questions, or culminating. So put that on the subject line, and then you can see that this is a PDF. It tells me that that's what's attached. Other ways, you can share it through Google Docs. So you can open your assignment in Google Docs. You can click on the share button. So notice there's an icon there. It's a lock. That means that it's private to you only. But once you unlock that to share, you can put in the box that will appear, put in my email. So you just type your teacher's email. You can have the setting on editor if you want, or you can just have it as view. Then you can send it to your teacher, and then we'll then have access to your document so we can print it for you. You could also have your DEC scan or fax it for you, or you can drop it off at 74 Front Street. There's our physical address here. We're right beside the post office. We also have a WASA outdoor mailbox on the side entrance. You can drop your work off there if you don't have time to come in. Make sure you put your name on your work so we know who it came from. And of course, if you have other concerns or questions, make sure that you call the office. So here's the course calendar for PLAR Science. It gives you week by week. And again, this is just, it's a guide so that you have time to complete it, complete all 5 lessons. That's if you're doing the key questions in the lessons. So in the first 2 weeks, we'll work on astronomy. Then in week 3 and 4, biology. Now biology is fairly short, so we might get that done before week 4. Chemistry is a bit longer, so weeks 5 and 6. Then we have physics, week 7 and 8, and then week 9 we have environmental science, and then you can also do your culminating. So remember, at any point that you decide that you want to go to the culminating activity, that option is still open to you. Now, if you're working on other PLAR subjects, like PLAR English, history, or geography from last term, try to focus on one subject at a time. So if you're still working on those and you've already made a lot of progress on, say, the PLAR geography, instead of doing the science, finish it up first, and then work on your PLAR science. Okay, try to complete the one that you have the most work on, okay, instead of switching between several subjects. Once you start submitting key questions, you will get this mark sheet. So it gives you, it's like a checklist. It shows you all the key questions that you need to do in lesson 1, all the key questions that you need to do in lesson 2, and so on. And again, you might get as far as key question 20, and then you might decide that you want to try the culminating. That's fine. So there are 80 key questions for PLAR Science. And for those of you who have decided to do the culminating activity, this is the mark sheet that you will receive. So once you send it, there are 5 sections for the culminating activity, just like the lessons. Part A is chemistry, Part B is biology, C is astronomy, D is physics, and E is environmental science. So this is an example of a student who did their culminating, and they were successful in completing it. So then they can move on to their next PLAR subject. The passing mark, or the minimum, you must get a 50%, okay, in order to pass the culminating activity. Okay, so here are the page numbers for lesson 1. So we are starting with astronomy. Page 5, we will look at the scientific method and the stages of it. Page 10, what is astronomy? Pages 11 to 15, we'll look at different terms like stars, constellations, galaxies, the Milky Way, and so on. Page 17, the solar system. Page 19, the sun and the structure of the sun. Okay, so it gives you all the page numbers for the different topics that we will cover. Learning goals, that just means what you will learn by doing lesson 1. I can explain the steps of the scientific method. I can describe the planets and other heavenly bodies that make up our solar system. And I will understand the challenges and benefits of human space exploration. So make sure that you pay attention to the bolded words. So here's an example. Here's a bolded word. Okay, it's darker than the rest of the words, so it's been bolded. And headings. Now the headings, that's the title. So that's a heading right there. In this case, the heading here is hypothesis. And then notice the word hypothesis is bolded, so it's darker. So pay attention to the bolded words and headings in your lessons, and feel free to highlight. So if you notice that, oh, that word is bolded, I'm going to highlight that because I know that's a term that I might need to know. So remember, this is yours now, like the lessons. You don't have to return the lessons to me. You just have to return the key questions. So in lesson 1, pages 5 to 9, you'll see some of these terms. So these terms will be bolded. Scientific investigation, scientific method, independent variable, dependent variable, hypothesis, experiment. So this is what it would look like in your lesson book if you're following along. So you can see the headings. So this one, the heading is the scientific method. That's the title of that paragraph. So everything underneath that heading is about scientific method. There's your bolded word, scientific method. Okay, and if you keep going, just hit the eraser here. There you can see there's another heading. It says question, and here are your bolded words, dependent variable and independent variable. Okay, let's continue with the next slide here. Okay, let's look at the scientific method. There's your heading. So in this lesson, you will learn about the scientific method. What it is a step-by-step process that scientists use to do research and experiments to learn new things about the world. So we will also be looking at astronomy, and astronomy just means, so again, there's your word or term, that is the study of space and everything in it. The word science, okay, comes from the Latin word that means knowledge. So when we think of science, it's just a way of gaining knowledge of the world around us. So it's a way of learning about the world by observing, asking questions, suggesting possible answers, and then testing those answers. So science also involves sharing the information gathered during an investigation. So the scientific method, as I mentioned earlier, is a step-by-step way to learn about the world. It usually starts when someone notices something and becomes curious about it. So people ask questions and come up with ideas or guesses. So guesses, these are called hypotheses. So they guess about why something happens. Then they test those ideas by doing experiments. So when they're doing the experiments, it helps them gather facts and then see if their ideas are right or not. So while the steps of the scientific method that can vary, so it can be different between different fields of science, most scientific investigations though share a few common stages or elements. So these include question, that again, like I said, you ask a question and then you research your topic. Hypothesis, your best guess. Procedure, writing very specific directions for experiment. And then the experiment itself, observing closely and recording data. Then data analysis, that just means you're organizing and then you're evaluating what you've learned. And then conclusion, what did you find? Was your guess right? Was your hypothesis correct? So some scientific investigations may skip one or two of these steps, and again, other scientists may follow these steps in a different order. Some of these steps, like observation and analysis, these are repeated over and over. Okay, so it's not the same for all of them, but they do have some in common. So let's look at an example of a scientific method in action, and we'll go over it step by step. So the first question is, and this is just an example, why do plants in sunlight grow taller than those in the shade? Okay, that's the question. That's what you want to find out. So the guess or hypothesis is plants grow taller because they get more sunlight. So now you have to do the experiment. So you can set up two groups of plants. One you will have in sunlight and one in the shade. Now the one thing that you keep constant is that you water them the same amount. Okay, so you're just wanting to find out if plants that get sunlight grow taller than the one that doesn't get sunlight. Okay, so you see a picture, you have one that gets water and light. Okay, there's the sunlight there. Oops. You just erase that. Okay, there's your sunlight. And then this other plant, this one doesn't have any light. They both have water, but one has no light or no sunlight. So now the data collection, that means you measure the height of each plant every day for 2 weeks. Okay, so you're just measuring the height. Analysis, now you'll compare the average height of the plants in sunlight with those in the shade. And then the conclusion, so if the plants in the sunlight grew taller, then you might conclude that sunlight helps plants grow. If not, so if you notice that, hey, it didn't make a difference, then you might need to change your hypothesis. Okay, so here's what happened. You can see the one with sunlight grew taller, and then the one that's in the shade is shorter. So in this case, the hypothesis is correct. And they might try it with different plants, or they might want to change the water content and so on. But for now, their hypothesis was plants grow taller because they get more sunlight. Okay, that's the guess that they were questioning. Okay, let's go over each of the step by step. So for a question to be considered scientific, it has to be something that we can test to find an answer. So here's an example. You might have noticed that a balloon sticks to a wall if you rub it on your head. So this could make you think, does the balloon stick better if you rub it more times? Or does the size of the balloon or its color make a difference? A scientific question usually explores cause and effect relationships. So these questions often sound like, well, what will happen to one thing if we change another thing? In our balloon example, a good scientific question could be, how does changing the number of times you rub a balloon on your hair affect how long it sticks to the wall? Now we're looking at two main variables in an experiment, and these are independent and dependent. So let's look at the difference between independent and dependent. So an independent variable is the variable that is changed or controlled in a scientific experiment to test the effects on the dependent variable. And then a dependent variable, that's the variable being tested and measured in a scientific experiment. So if you look at the balloon, or rubbing the balloon on your hair, so the one thing you can change, so you limit to only one in an experiment. So in this case, the number of times the balloon is rubbed on the hair. That means you can control it. So you might say, I'm going to rub the balloon 5 times on my hair. The change that happens because of the independent variable. So example, how long the balloon sticks to the wall. So you might time it. So once you put it on the wall, you might have a stopwatch to see how long it stays up on the wall. Okay, the hypothesis, that's the possible explanation. So it's an educated guess based on what you already know. So you already saw that if you rub the balloon on your hair, it sticks to the wall. You might come up with a hypothesis that the more times you rub the balloon on your head, the longer it will stick to the wall. So hypothesis, if you were to write it, the more times you rub the balloon on your head, the longer it will stick to the wall. So this then is tested so that you can gather evidence to prove or disprove your educated guess. Okay, other scientific hypothesis examples other than the balloon, you can say plants require liquid water to survive. This would be disproven if you find a plant that doesn't need it. Another hypothesis, classrooms are noisier when the teacher has left the room. Or another one, objects made of metal will sink in water. So these hypotheses can be tested. Okay, experiment. An experiment includes a list of materials that you will need, and you will also need a procedure. That means how you will carry out the experiment. It's important to write the experimental procedure clearly, concisely, and accurately. So that means that if somebody else were to have your experiment, then they should be able to do it. And then they can also understand how you did it so that they can repeat it. So here are the materials you need to test how rubbing balloons on your head affects their ability to stick to a wall. So you can make a list. You might write down balloons, several, preferably the same type and size. You can use your own hair or someone else's, wall or vertical surface where you can stick the balloons. You might need a measuring tape or ruler just to measure how long the balloon sticks. Timer or stopwatch that will track the time the balloon sticks to the wall. And then have a notebook and pen or pencil to record your observations and results. Okay, so that's just the list of the materials that you will need to do this experiment. Now the observation, So we have a breakdown of the important points for recording results during your experiment. You have to record them, so make sure to note your results carefully. Conduct multiple trials. That just means that you do several times to make sure your results are consistent. You don't do it once or twice and say, oh yeah, the balloon is sticking to the wall for a long time by the number of times that I rub it on my hair. Okay, try to do several trials just to make sure that it's consistent. Data format. So you might include numbers. So for example, with the balloon, you will write down, by using your stopwatch, you're using numbers. Say if I rubbed the balloon on my hair 20 times, it stays on for 15 seconds. Okay, this one is important. Keep all data. That means don't throw away any data even if it seems bad. So if it doesn't support your hypothesis, don't throw it out. Many researchers have made mistakes by throwing out results that didn't match their expectations. Okay, exceptional notes. If something unusual happens during your experiment, make a note of it. Write down any other observations that's related to your experiment that's not directly about your hypothesis. It could be the humidity, temperature, vibrations, other noteworthy events. So maybe when you're doing that experiment with the balloon, maybe it was really hot that day, or maybe you tried a different day and it was very cold that day. By keeping detailed notes, that will help you analyze your experiment better. Now, when you're collecting observational data, that means things that you can see, it's a good idea to use a table to record your information. So after you've noted your observations, then you can organize that information into a graphic display. So graphs and charts make it easier to identify patterns and trends in your data. For example, they provide a simple way to see if a relationship or pattern exists between two or more variables. It also describes the relationships, so graphs can help you explain these relationships accurately using words or math. And support for hypothesis, so the graphs and charts can also help you determine if your observations support your hypothesis. So basically, using the graphs will make analyzing your results much easier. So for example, here's a graph. Now, this is the legend. Basically, it tells you the blue is for plant A, the red is for plant B, that's moved into the closet, and then plant C is moved onto the windowsill. So the hypothesis here is, does the amount of light a plant get affect how quickly it grows? So starting on day 1, you can see on the chart or graph, they're all the same. They're all at 1 centimeter. Day 2, they're the same. Day 3, day 4, day 5, they get up to 2 centimeters on day 5. Now look what happens on day 6. Okay, without reading any notes, just by looking at the graph, plant A, which is the blue, okay, it almost got up to maybe 2.1 centimeters. The one that was moved into the closet did not move at all, so it didn't grow. But plant C, that was moved onto the windowsill, went up to 2.5. So again, continuing on, by day 10, notice that the plant, that's plant B, okay, the red, that was moved into the closet, it actually got shorter. Okay, it started at 1 centimeter, now it's barely 0.5 centimeters. The plant that's been moved onto the windowsill, on day 1 it was at 1 centimeter, by day 10 it was at 4.5 centimeters. That's how much it grew. And then the plant A, that's been, it's the control, that one only went as far as not even 3.5. So again, I didn't have to read the experiment. All I did was look at the graph, okay, to let me know that does the amount of light a plant get affect how quickly it grows. Okay, analysis. So then once you finish the experiment and you note your observations, you have to look at all the data to see if it supports your hypothesis. So if it does, then that means you've answered your original question. Okay, on the other hand, if the data does not support your hypothesis, the scientific inquiry continues, and that just means you would do more research to create a new hypothesis and then conduct another experiment to test it. So this process keeps going until a hypothesis can be proven correct through scientific experimentation. Okay, then you have a conclusion. And a conclusion is just a statement that explains the results of your investigation or the result of your experiment. This statement should relate back to your original hypothesis and tell whether the results support, partially support, or do not support it at all. So don't be discouraged if your hypothesis isn't supported. Scientists often have to revise and repeat their experiments many times to find the answers they need. So you state whether your prediction was confirmed or whether your prediction was not confirmed, and then you have to explain your results. So for example, you might say, my hypothesis is supported, my plants grew better in light. So scientific work doesn't stop after just one experiment. It can be repeated multiple times. So there's some guidelines that help you come up with ideas for further experiments. So you might consider repeating the experiment using a new or improved design that addresses any issues that were identified. You might want better equipment so that you can take more accurate measurements. You might have a revised procedure so that you can gather more evidence in your experiment and improve skills in using the equipment. So you're reviewing the hypothesis and then you just look for new ways to test it or suggest a new one. Okay, so those are your options. Okay, let's try and do some key questions. So this is what your key questions look like. So remember, when you're answering the questions, please use the materials that's provided. Don't try to look it up on internet or Wi-Fi to search for your answers. And again, you only send me the pages where you have the key questions. Okay, don't return the lesson to me. You can keep that so you can use it for review. You will notice that each lesson will have this information. It will give you the WASA studio number. It'll give you our radio channel, which is 91.9 FM if you're within the Sioux Lookout area. And if you want to, you can listen to it online. So we've given you a link to listen to the online radio. I also have my Zoom link there with my meeting ID and a passcode. The office number is there. My extension is there. The fax number, toll free. My email. okay, is provided on that cover page. My work Facebook, so that's J Mercer Wassa. The link for our YouTube is also there, and if you have family or friends who are interested in applying, the WASA registration link is there as well. So everything on that page, on the cover page, is what you will need to get a hold of me, or if you want to check out other things that we have available for you at WASA. Okay, so it shows you the lesson. Okay, in this case is lesson 1. It gives you the topics. It gives you the key question number. So in this case, up to key question 26. And then on the right hand side, on that column, it gives you the marks for each question. So notice some key questions are weighed more than the others. For example, number 2, the scientific method, is worth 18 marks. Number 10 is worth 20. Key question 20, there's a table there that you will need to complete. That one is worth 35 marks. Okay, last year's key question number 2 is different from this year's key question. And we will go over that. So again, if you have the older version and you completed it, that's fine. But I just want to point out that the key question 2, it's the same question, but I've changed the format of it, and I will show you in a moment. When you do the PLAR Science key questions, you will come across 3 types of questions. The first type is a hand question, and hand questions just mean questions where you can put your finger or hand right on the answer in the text. These are usually right there questions because the answer is easy to find because it's written directly in the reading. So for example, when you read the information, scientists estimate that the sun will continue producing energy for about another 5 billion years before it runs out of fuel. A hand question would be, how much longer will the sun keep producing energy? Okay, you can put your finger on the answer or your hand. It's right there. It says 5 billion years. So that's the answer. Another one, what is a scientific investigation? Okay, there's the bolded scientific investigation. Is also a way of learning about the world by observing things, asking questions, proposing answers, and testing those answers. Okay, the answer is right there. You can put your hand on it. Okay, that's a hand question. It's very straightforward. Now, another type of question you will come across is a head question. Now, these questions, the answer is not written word for word in the text. You have to think, infer, or you use your own ideas to answer it. Here's an example of a head question. Why might people want society to build places for people to live in space? Okay, so this is a head question because the answer is not written directly in the text. Okay, you have to think and give your own ideas. Okay, is it a heart question? Okay, there's another, not hard, heart. Heart question would be like, in your opinion. So here's an example. In your opinion, is human exploration of Mars a good idea? Why or why not? So this is a hard question because it asks for your personal opinion and it's your feelings. Okay, there's no right or wrong answer. It just depends on what you think. You might say, yeah, that's a great idea. You know, the more we know about other places, the better. Or you might say, no, I don't think that's a good idea. Okay, because I was reading a section about Mars, and it says that they found some life there, but there's really no evidence that there was anything actually alive on the planet. So I think that might be not a good idea for people to go there, okay, if there's no life there. Okay, so again, there's no right or wrong answer for hard questions. Okay, so let's try the first key question. Answer the following questions in complete sentences. The first one is worth 2 marks. What is a scientific investigation? You can start with a scientific investigation. So you're writing it out so that you can write in a complete sentence. Then you write down what it means. Okay, key question 2. So this is where I said it was different. Let's view a dual page here. Okay, so last year the format was that identify and explain the 6 stages of the scientific method. You were given 1 mark for the name and 2 marks for your explanation. So you would write the stage here. For example, you would write question, and then you would give me the brief explanation. Okay, that's how you will get your marks. This time, what I did was, let me just put it up here now. This time, all I want you to do is you match each of the 6 stages of the scientific method. So you have column A. These are the stages. It says so right there, stages, column A. The next column, it says explanation, is column B. Notice there are letters beside each explanation. So A, B, C, D, E, and F. Okay, now I've gotten some answers for this question, and I'm not sure if it's confusing because I'm getting answers that says A, B, A, B, A, B. I only want you to use each letter once. So you can't do A, B, A, B. The first one is question. So look through the explanation in column B. You have to choose whether it's A, B, C, D, or F. Okay, that's your first task. If you remember that number 1, question, to be considered scientific, you must be able to test an idea and answer the question. So that means that the first one, the correct answer is F. So now I'm going to cross off letter F, and that's where I will write my answer. There's a space there for you to write. That means I can't use the letter F anymore. Number 2, hypothesis. Okay, now my choices are A, B, C, D, or E. Okay, hypothesis, if you remember, blank is a possible explanation of why one variable affects another. It is an educated guess based on previous knowledge and experiences. So number 2 is the letter C. So now I've crossed that off. Okay, let's try one more before we go. I could try a couple more. A few more minutes. Let's try observation. Okay, observation is number 4. Which one would that be? Okay, number 4, the correct answer is A. Okay, as the experiment is conducted, it is important to note down the results. In any experiment, it is necessary to conduct several trials to ensure that the results are consistent. Okay, number 3, experiment. Which one is experiment? Now I only have 3 choices left. Is it B, is it D, or is it E? Okay, it's D. The experiment consists of a list of materials needed and a procedure. Okay, so 3 is D. Okay, number 5, analysis. So you only have 2 more choices. Is it B or is it E? Analysis is B. After conducting the experiment and recording your observations, you will need to analyze all the data and use it to draw a conclusion regarding the strength of the hypothesis. Okay, so number 6. Oops. Okay, so that was B. So number 6, conclusion, you have 1 left, which is E. It should reveal whether the results support, partially support, or do not support the hypothesis. So that is the answer. So this is what it should look like. So question is F, hypothesis C, experiment D, observation A, analysis B, and conclusion is E. Okay, so when we come back on Wednesday, we'll continue with the other key questions for lesson 1, and then we'll let me just bring that up here. We'll look at the next section, which is what is astronomy. Okay, thank you for joining me. Miigwech.